So the take-home message here is we have to adapt to where we are. In October or the next spring, we have to adapt with those situations that are presented to us. Now if we go to the annual precipitation, again we're talking about that risk across that expected precipitation, and these are the 80, 50, and 20% probabilities. That means that the 12-inch for this location is, we're going to get that 8 out of 10 years, and the 19 will get 2 out of 10 years. So that gives us a range of those probabilities of precipitation. We go across there and see that, yes, with more precipitation, you bet, we'll get more net return. And then ET, we have the ET losses there when you have more precipitation again. The soil can't hold it all. You have more drainage, more non-growing season evaporation. And we're back here. We've changed to 12 inches of irrigation. We were looking at 6 inches before. So keep that in mind, too. We're in a better situation over irrigation. Let's see. Is that all I was going to check? This is the last example I have in this particular situation. There are many, many more things that we can look at. For instance, the big influences we're talking about right now are the availability of soil water and then the precipitation that we might expect. We can also look at putting our schedules in different parts of the growing season and see how that yield response comes out, because our model is sensitive to stressors during different parts of the growing season. Researchers have shown us for many, many years that the most critical period for applying water is during that vegetative or reproductive period and holding back some of the water. We can go in and put in irrigation schedules to emphasize, if we can have the capacity to do it, to emphasize the water at different times of the growing season. Examining that starting when you start that irrigation at the irrigation season and when you stop it, so that we can again play with that when we're going to put on that water within our constraints. And we have constraints now. We're going to have constraints on water as we go down the road even more. So I think this type of approach, putting on our thinking caps to right now sit down with these tools and say, what do I have, what do I expect, what might be the outcomes. The numbers I've shown you as far as the net returns, I would like you to think about that in trends, because with anything, when you're trying to estimate out there, there's what I call the unknown factor, or how much variability there is. So if the number, you look at a number, what do we predict, the net return, it might not be the actual number. It's the best we know with the tools we have. But we want to look at the trends. Is the net return going up or down with these different situations, scenarios we're putting in? Now, if you introduce these programs to these types of users in our early sessions, or training sessions, and we do have these type of potential users even into the classroom. Students going in and examining these options. Irrigation specialist, I would expect my colleagues to go into this program, sit down and use it immediately. We have a whole user's manual and help sections in it to help people going, but I expect my colleagues to be able to sit down with it. On other people, like yourselves mostly, I would have to see some training needs, maybe an hour for the crop water allocator, 2 hours for the crop yield predictor, and we're setting up more and more of these sessions in Kansas, and we have these ready to go. In the Texas situation, I would anticipate doing more of that down here, but it does take some understanding of getting those inputs in and getting the proper outputs coming back to you. And again, if you're the more computer literate you are, the better we're able to get into the program. We had some training sessions Nick and I did last winter where we had some sharp producers. They knew their cost, and really good producers, and also they weren't afraid to go charging into that computer, and they were ahead of us. We were still explaining some things, and they're already picking away back there trying to see what would happen in their situation. So we hope that these are models where we put science into something, a tool that you can use in your management situation going down the road. They're available at a website right now. If you want to go in and tinker with them already, at this mobileirrigationlab.com, if you want to take that down, as part of it, and they are downloadable. So you get to that site and go to the crop yield predictor or the crop water allocator, and you can then download it on your computer and use it on your computer. We also have some technical manuscripts that go into the background of this, especially for my colleagues, so we can see, again, testing these against real data, how these come out. So we have that in there, and we have, like I said, we have a manual you can go to. Lots of people say, well, I don't want to read it, but we have question marks every place through the program, so you can go over to that section of the manual if you need some more help. So we're trying to make it something that you can independently use, go in there and use your head. Okay. Questions? I went pretty fast. We have some time. Okay, I have a computer here with me. The program's loaded. And if you want to come and sit down with me individually or at a couple of us together, I can pull these up and give you a little more demonstration. Today I wanted to show you what they can do for you.
Yeah, my question is that this obviously relies pretty heavily on the relative crop yield versus rainfall, which you said that you got from experimentation.
Experimentation rolled into a crop model.
Okay.
So the smooth curves that you saw of yield, relative yield versus irrigation for different precipitation, that came from the model, but research inputs went into the example of the yield, ET relationships, soil water stress, crop water stress, all came from research.
My question is really related to what's going to be involved to bring that down to the panhandle of Texas.
Okay. One thing is the soils. We have deep silt loam soils and we have fine sands. And that's where we've calibrated. One of the things that Nick and I are working on is we have to calibrate for the clay loams that you have. So that's particularly for the drainage size and getting the fill capacity and the permanent wilting points determining for that soil. It's soils dependent on that side. If there are differences in the yield ET function, we'll have to put that in for the crops down here.
You're not anticipating the need for experimentation to make this work?
We don't think so. We're trying to draw from the research that Texas folks that we have out there. So we're trying to do as good as we can based on the research that's been done and the knowledge we have for those inputs, basic inputs. So we're working on that. I haven't even talked to Nick about something I'm thinking about we can do and generate those curves a little bit even easier for Texas or other places. The structure and the scheme of the model, I think it can go farther. Okay, I'm not going to hold you out a break. Nick?